So if we wanted to look at adding resistors, think about that. Resistance is equal to rho L over A. It's dependent upon the material, it's dependent upon the length of the material and the cross-sectional area of the wire. So if I have a really long wire here, we'll pretend that's really long. If I have a wire here of some length and some cross-sectional area here, well, if I just think of this as two different wires of length L1 and L2, I know that L1 plus L2 is equal to L. So my resistance is rho L1 plus L2 over A, which is rho L1 over A plus rho L2 over A, which would be resistance 1 plus resistance 2. So if I have a series here, so if this is a resistor here and that's a resistor there, in series I would just add them up to get the equivalent resistance. So for resistors in series, the equivalent resistance is just the sum of all the individual resistances. So just doing a quick look here, if I have a 5 ohm resistor and a 4 ohm resistor, I could potentially just take both of them out and replace it with a 9 ohm resistor. Also note, if I have a circuit here with my two resistors, R1 and R2, any current that flows across this resistor has to flow across that resistor. It is the same current flowing across both resistors. Now let's take a look at parallel. I now have, again, my power supply. I have a resistor here. I have a resistor here. I have some current that's flowing along this way right here. I know that delta V is equal to IR, Ohm's law, which presumably has been derived in a previous video. Some resistance 1, R1, some resistance R2. Whatever current is flowing out of the battery here will get to this junction and split. So I have some current flowing out of the battery, it's going to split, and I have I1 going this way, I2 going that way. Just think about it like a river. River comes to a fork in the river, and some goes one way, some goes another. But the total of what goes out equals what goes in. This is also Kirchhoff's junction rule, or current rule. So whatever my voltage is here, that's going to be equal to this current times my equivalent resistance. I know that current is equal to I1 plus I2. So that's I1 plus I2 times my equivalent resistance. Now I1 going across here, again, Kirchhoff's rule, Ohm's law applies. And so delta V1 is going to be equal to I1 R1. So I1 is just delta V1 over R1, just dividing. Similarly, I2 is delta V2 over R2. So I could plug those into there. So I have delta V is equal to delta V1 over R1 plus delta V2 over R2 times R equivalent. Now my voltages actually are all the same because Kirchhoff's loop rule, whatever I gain here, I'm going to lose there and I get back to where I started, or go this path. Whatever I gain here, I'm going to lose there. The voltage drop across here has to equal the voltage gain here. In other words, delta V is the same for all of them. So I can factor out delta V and cancel it out. So I'm left with 1 is equal to 1 over R1 plus 1 over R2 times R equivalent. I can divide both sides by R equivalent, and so I get 1 over R equivalent is 1 over R1 plus 1 over R2. And so for resistors in parallel, 1 over the equivalent resistance is equal to the sum of all the individual ones. So just a quick little problem right here. Let's say I go for my 12-volt battery again. I throw in a 5 ohm resistor and a 4 ohm resistor. My equivalent resistance, 1 over my equivalent resistance, is 1 over 4 plus 1 over 5, which is 0.45. And so my equivalent resistance is 2.22 ohms. We can now find the current flowing out of this, that I know the current flowing out of the battery, that's going to be 12, plugging into this formula, is equal to I times 2.22. So the current flowing out of the battery, 5.4 amperes. Now it's going to get to this junction here, and it actually is going to split. Most of it is going to go this way, less of it's going to go that way. We can find out how much is going this way. We could just do a voltage, we could just do a loop here. And so I gain 12 here, I lose 12 here, so this has to be 3 amperes flowing that way. Again, plugging into delta V equals IR. And therefore, this must be 2.4 amperes flowing this way, because what flows in flows out. Or I could just do 12 divided by 5. That works on this very simple example. We will do more complex examples where that is not as readily obvious.